To start, we wanted to begin with some background information on stoichiometry by reviewing its process and how to implement it within experiments. Stoichiometry can be defined as the quantitative relationships between reactants and products. Stoichiometry follows the law of conservation. This means that matter is neither destroyed nor created. The limiting reactant is the first reactant used up in a reaction, which limits the product. A precipitate is a substance in solid form that is part of a solution, and a supernatant is a substance in liquid form as part of the solution. We can use the example of making a s'more with 6 graham crackers and 6 marshmallows to highlight the different parts of a stoichiometry problem. For this example, the graham cracker is the limiting reactant because 2 would be needed for each s'more while 1 marshmallow is needed, making the crackers run out first with a final product of 3 s'mores and 3 leftover marshmallows. For our specific lab, we used this equation. It was evident that this reaction was a double displacement because the anions in each compound switched. The purpose of the lab was to examine the reaction between 2 solutions in different rations to determine the limiting reagent. We would do this through using a variety of test tubes, each with 5 milliliters of copper 2 sulfate with an increasing amount of potassium hydroxide, 1 milliliter up to 8 milliliters, and finally adding distilled water until each tube was at 13 milliliters. We observed that copper 2 sulfate was a bluish liquid, while the potassium hydroxide was clear and see-through. We first started by dripping the copper 2 sulfate down into the test tubes numbered 1 through 8. Using berets, we made accurate measurements, moving to add the potassium hydroxide by adding increasing amounts. After adding the water, we ended up with 8 different test tubes. We stirred the compounds together and had the tubes sit for 15 minutes. We observed the separation of the precipitate and solid substance from the supernatant. The clear bluish is liquid. Throughout the lab, we observed the precipitate build up in varying amounts and separate from the supernatant. Our findings were that there was a buildup of 5 milliliters in test tube 1, 8 milliliters in test tube 2, 41 milliliters in test tube 3, and 60 milliliters in test tube 4. After that, the levels of precipitate leveled off around 68 milliliters in test tubes 5 through 8.
We observed that in test tubes 1 through 4, the KOH is the limiting reactant portrayed by the growing levels of precipitate that mirrors the added level of KOH. In test tubes 5 through 8, the limiting reactant is the CuSO4 because the amount of precipitate stays the same even though the amount of KOH continues to rise. The sources of error in our lab were pouring too much and too little copper 2 sulfate in test tubes 6 and 8. Having to lift the tubes up and measuring them created a source of human error, and having the precipitate sit too much when stirring. This caused them to have values of 68 milliliters in test tubes number 6 and 59 milliliters in test tube 8.